Good afternoon, ladies and gentlemen. My name is Michael Watson, and I lead our reactor program in the Asia Pacific. I'm really excited to welcome you all for this event, the Well-Architected, the Backstage tour. Today you'll hear from two fantastic presenters who will introduce you, who I will introduce shortly, and they'll discuss topics around reliability, security, cost optimization, operational excellence, and performance efficiency. Not easy to tackle when it comes to your cloud workloads. We're going to take you behind the scenes at Azure, where you'll get 5 brief peeks at how we power the features that address each of these pillars of the Azure Well-Architected Framework. Not only will you learn how things work behind the curtain, but you'll also take away some tips and tricks you won't find anywhere else to help us with these subjects. Now, today we have the good fortune of having two fabulous presenters. So we have Shane Baldacchino, who is our chief architect at Microsoft Australia. Each day, as a trusted advisor, he challenges businesses and peers to think differently, learn more, and make complex simple. His experience spans startups, Australian tech unicorns, through to some of the largest born in the clouds, and he uses his war wounds as experience to act as a thought leader to help others to see around corners and advance the maturity of our customers. We also have Paddy Quensel, who has been in the ICT industry for over 14 years. Paddy has a deep passion for increasing the market's capability and skills, realizing innovation and applying a Kiwi can-do approach to everything he does. That passion for innovation began with his career at Nike, and now he's focused on working with organizations across Australia and New Zealand who are keen to leverage that innovation combined with Microsoft's digital transformation solutions to help them achieve more. Now, we're going to go through a number of topics as I've discussed, but before I hand over to these two gentlemen, we're going to watch a short video by Microsoft Azure CTO and Technical Fellow Mark Rusnovich. Now, one thing also to take note is that we do want to encourage questions. So if you have questions throughout the session, please feel free to post them in the section on the side of your YouTube stream, and we will endeavor to answer them either during the stream or afterwards. Without further ado, I will cut over to our next video. Thank you.
Welcome to Well-Architected, the Backstage tour, and thanks for joining us. This is my kind of event, and I think you're going to love it too. We get to talk about topics I'm really passionate about: reliability, security, cost optimization, operational excellence, and performance efficiency. All these areas are critical for workloads to be successful on Azure, and it's Azure's goal to make it as easy as possible for you to be successful. What's great about this event is that we'll show you some of the hard work we do here in engineering behind the scenes. And with that tour, we're going to include a lot of insider tips on how you can leverage that work to run your cloud workloads so that they thrive on Azure. To keep in the spirit of this event, I thought I'd share some of my own behind the scenes looks at Azure. Every year I give Inside Azure Data Center session, the most recent one at Ignite in the spring. And here's a little clip that shows you behind the scenes of Azure's data centers.
Another great place that we're applying Resource Central is in minimizing customer impact towards failures that we think are imminent. And failures that are imminent would include ones where we're getting signals from the hardware in our servers that it's starting to produce errors. Those errors might be correctable at this point, or there might be a failure of a component. That component is not impacting any virtual machines, but signals that that server is going to be moving likely into a degraded state. And we're using Resource Central to take those signals, create these models of how a server is going to perform. How likely is it going to fail? What's the timeline before it fails? And then also figuring out the best ways to respond to that. In some cases, it just means resetting the server. It could be a software-induced failure, and we might need to do what's called a kernel soft reboot, which means just resetting the hypervisor environment, but leaving the virtual machines preserved in place through that process. And Resource Central, and through Project Naira, has been operating now for about a year in production. And as a result of it applying this kind of intelligence to prediction and the best way to mitigate the impact, we've seen a 26% decrease in VM interruptions, meaning some software or hardware problem on the server is causing an impact to virtual machines. So already huge impact, and we're just getting started with this kind of capability.
So coming back to the Azure Well-Architected Framework, which is our set of guidance and best practices for workloads, it has exactly the pillars I mentioned earlier: reliability, security, cost optimization, operational excellence, and performance efficiency. And like the behind the scenes you just saw, where we're building things to satisfy multiple different, often competing needs, the well-architected framework also recognizes that nobody has the luxury to pay attention to just a single pillar. The WAF is there not only to show you how to help build good stuff from start by asking the right questions, but it also acknowledges that the real goal is to try to keep things in a well-architected state. In order to do that, you will find yourself negotiating between the pillars. That's why I encourage you to stick around for all of the sessions, not just the ones for subjects you're immediately involved with, because you'll see them all show up on your doorstep at some point. With that, let me tell you a little bit about the event. Following this keynote, we'll have 5 separate 15-minute sessions with live Q&A after each. They're all going to be fantastic. So allow me to welcome you to behind the scenes at Azure, here at Well-Architected, the Backstage Tour.
Thank you very much, Mark. Okay, now without further ado, I will hand over to Shane. Welcome, Shane. Shane is, as I said, our Chief Architect, and Shane will be running us through the first of our sessions. Over to you, Shane.
Thanks, Michael. And wasn't that a great message from Mark? So hello, listeners, and thanks for tuning into Microsoft Reactor today. Look, for those who have not yet met me, my name is Shane Baldacchino, and I am the Chief Architect for Microsoft Australia. So I'm really excited to be joined today by Patrick, which you'll soon meet, to talk through one of my favorite topics in the era of cloud, and that is well-architected. Now, why is this one of my favorite topics? Look, this is something really close to my heart, as embedding a culture of well-architected in customers, helps you understand trade-offs, and in many cases prevents many difficult conversations in the future. So it's a story of prevention is better than cure, right? So look, if you are a builder, which I know we all are, Well-Architected is a great read for anyone starting out, not only in cloud, but in software design in general. But today, this is the Backstage Tour. So we're going to spend, the next hour and a half or so together and give you the lowdown on how we do things inside Azure here at Microsoft. How are we Microsoft well-architected? So look, get comfortable. We're going to start this event talking about reliability. If you do have questions, as Michael mentioned, pop them in the chat. We encourage you to use the chat. And then at the end of each session, we'll address these questions. So look, we know that when someone wants a virtual machine in Azure, they want it fast. Whether you're pushing a button on the portal or you're sending an API call, the desired outcome is the same. So I'm going to show you how virtual machine provisioning happens and take you behind the scenes on some internal platform capabilities that can speed up your experience. Now, along the way, I'll share with you some, black belt ninja tips on how you can leverage these technologies. So look, creating a virtual machine, pretty much means never just a virtual machine, by itself, by its lonesome here. Later in this event, we'll talk through ARM templates. Hopefully you're familiar with these already. So, creating a VM includes the creation of many additional resources, some required and some only needed depending on your workload and goals. So, you'll have the network interface card or NIC, the interconnection between the VM and the virtual network. Then you'll have the network security group along with a subnet, and that subnet is part of the VNet or virtual network. And if your workload needs more data, you can have associated, data disks. And if you want to get information about your VM during the boot phase, you can get the diagnostic logs and screenshots, and you can pop that in a storage account. And then, of course, you have the IP address in order to interact with the VM. And on top of the additional resources, there are choices to make for the VM itself. The size of the VM, the OS, the image, the distribution and version, and the availability options. There are so many selections to choose from in order to fit your workload needs. And I'm going to share how you can optimize for performance and reliability, as well as give you a sneak peek behind some of the platform capabilities that you can leverage to enhance your experience on the Azure cloud. And I think, in the video we just saw, Mark, briefly just touched on this. So when you think of, conventional resource provisioning, everything happens on demand. As a customer, you might log into the Azure portal, or, you might open up the CLI window, using AZ CLI, maybe Azure Cloud Shell, to create a virtual machine that you want. Now, when that request comes in, the virtual machine and all the associated resources that you asked for, which we saw on the previous slide, are put together at runtime. So we build the machine up and run it through provisioning, which, it can take time. Akin to as if you were installing Windows on your laptop for the first time. For Windows, you go through the Windows setup process and then the Windows provisioning agent. And for Linux, you're using Cloud Init. This process is all about building all the resources together at the time of a request. The virtual machine itself, the NICs, the storage accounts, the data disks, etc. Over time, we've created optimizations to create these resources faster for you, and improve the experience. And, this is a journey that we're going to dive into so you can, learn how to leverage and take advantage of these. So the first optimization I want to talk to you about today is prefetching. When Azure was in the beginning, rewind the clock, we made a conscious decision to put the OS disk on remote storage. That way, if there were any issues on the host node, we'd spin up another virtual machine on a new node and the user wouldn't be impacted by loss of data. So this was a bit of a trade-off. So this additional reliability was traded off against performance. And of all the steps that occur in a conventional provisioning, there is one specific step that takes the longest. That is, that's this prefetch component here. Now we're trying to optimize this and we are continually, working on this process. The goal of prefetch is to reduce the latency that is incurred between the node and the storage by bringing the OS contents down to the host node before they're needed. So we're prefetching, but because we can't bring everything, we try and determine, which ones are needed as accurately as possible. So when a new image gets published to the image repository in Azure, so we're talking the platform image repository and the shared image gallery, the prefetch service is invoked in the background. And what the prefetch service is doing is bringing up a sample VM with that image to learn the OS disk activity that occurs during boot and provisioning. So a bit of machine learning happening here. This metadata is captured and then put back on the OS disk, which we call prefetch metadata stamping. So we're stamping that metadata on the OS disk. When a VM is booting on the host node, it will check for prefetch metadata and read it prior to the guest VM starting. So I guess the number one tip here, the first ninja tip is, if you are building your own image, please ensure that you leave the first 1 meg of the OS disk empty so we can stamp prefetch metadata. This will ensure that your image is prefetchable, and this will yield significant latency gains, when that image is being instantiated. Now, if you are building your image from an approved base, you don't need to worry about this. Just looking at the chat here, if you do have comments, feel free to leave comments, questions, etc. in there, and we'll love to answer them later. So on to diagnostic storage. So, we are doing optimizations here. So boot diagnostics is a debugging feature in Azure for virtual machines that allows diagnosis of VM boot failures, kind of handy here. Boot diagnostics enables you to observe the state of a VM as it's booting by collecting log information and screenshots. In order to have diagnostic logs and screenshots that provide insight into what happened during the VM provisioning process, you need to select a storage option for this data to be retrained. Previously, you only had the choice to either leverage a user-managed storage account or disable the feature. For the user-managed storage account, if you did not have one already, you'd have to create one, meaning another resource being created at runtime along with the VM. With a new managed account option, you can get the diagnostics without needing to manage or even create a storage account for it. How cool is that? These storage accounts are pre-created ahead of time, resulting in a minimal latency to be incurred by this associated VM resource. And these accounts are managed by Azure, making this easy for you. So taking all of this into account, black belt tip number 2 here is to leverage managed storage accounts for VMs if you can. This will reduce your VM provisioning latency, as you are, reducing this management overhead. So the next platform capability I want to share with you is something called pre-provisioned virtual machines. Hopefully you can see where I'm building up to. This platform capability seeks to remove as much of the resource creation at runtime as possible. There are 3 high-level steps to pre-provisioned service. The first is a prediction where we analyze the VM deployments across all of Azure and predict what will be needed from the platform in the future using AI capabilities. This prediction is then leveraged to prepare VMs in advance of a request coming in. And these VMs are kept in a partially provisioned state. And the last step is what we like to call activation, where final configurations specific to customer requests are applied and the VMs are then handed off to customers in a fully provisioned state. So what does this mean for you as a customer? First thing is, significantly lower latency experience in VM deployment because, these are pre-provisioned. The need to boot the virtual machine at the time of a VM request coming in is removed, and this is a very positive impact on the duration of creating VMs. The other is reliability. Because the VMs in this pathway are already up and running, they don't have to go through a reboot, and there are fewer interactions where things could fail. But let's dive into each phase in a bit more detail. So millions of virtual machines, as I'm sure you can appreciate, are deployed every day in Azure. And our algorithms look at the history of all these virtual machine deployments and predict what VMs will be needed in the future for our customers. As we went over in the beginning, there are a lot of different selections available, to customers for virtual machines. These properties, I guess, could be bubbled up into 2 categories. So we've got pre-provisioned, from a service perspective, things that are immutable and I guess things that are not. And I guess you might be asking what makes things immutable. And the answer is, if it needs a reboot, I can't make a Linux machine into a Windows machine. So I need to be able to predict the operating system. I also, think about Linux here. I can't make a Debian image into, say, a Databricks image. So I need to predict for the VM the image. On the other hand, I can change a username, I can change a password, or even the machine name at runtime. So this is a principle that guides us to what we need to predict for versus handle on the fly. And believe it or not, the number of possible VM configurations comes close today to 70,000. Look, and a quick note on the algorithm. So we have a team of, very talented set of data scientists. They've created a new framework in order to best approach this problem. The prediction component predicts the future demands and models prediction uncertainty, which is inevitable. And the optimization component conducts probabilistic optimization, factoring in, the most beneficial customer experience. So think in terms of a capacity crunch here. What's going to benefit, most of our customers here? We're going to go through a period of training because remember, machine learning, you've got training and inference. So we're going to go through a period of training to maximize the solution quality and then, finalize this pre-provisioning plan. This is obviously, for any of you who are involved in machine learning, a very simplified description. But look, if you are interested in learning more, we'll leave a couple of our links at the end of this session. So, as you can see in the slides here, we've got a bit of a feedback loop, and this is continuous here. So we've got the historical data, it's going through a prediction, it's being modeled, and it's being optimized, and it's turned into a model at the end. So once a prediction is received, we'll go through another level of platform filtering in order to scope the maximum number of predictions, balance out with capacity needs and so on. So, a lot of things are happening here. From the platform perspective, it actually seems like, we're just creating a VM, like usual at this point. The only difference here is these VMs are tagged as pre-provisioned to denote a special functionality. Inside the guest is where the difference is known. It understands that this is a pre-provisioned VM and it's not a regular one. It will go into a mode where it's waiting for customer-specific settings to be applied. So basically, we have an agent running inside the guest that's doing all this magic. But rest assured, from a security perspective, I just want to call out that these VMs, they have no public IP, they have no internet connectivity. So this means no one can connect to them and they're secured and just sitting there in a dormant state waiting to be used. Okay, so on the activate side of things, when a request comes into Azure with a virtual machine configuration, matching one that has already been pre-created, pre-provisioned, we can give that VM to the customer. So we're cutting down the time here. The agents are taken out of the waiting mode by getting supplied information that they're looking for. They're after the username, they're after the password, perhaps maybe using an SSH key, the machine name. And the process of finishing up provisioning and handing off the virtual machine to you, our customers, can begin. A transfer of resources and billing to the customer occurs. Once this is complete, we relinquish any control over the VM, and it's fully owned by you, the customer. Now, while there are some really innovative technical details that happens here, for these pre-provisioned virtual machines, some ingredients to this secret sauce must remain secret. So we can't tell you those today. So I guess the big question here is, you've seen this. What can you do? This is great stuff. How do you leverage it? Now, because pre-provisioned virtual machines being an internal platform capability, as customers, you don't have any interactions with this. As I said before, there's around 70,000 VM permutations, and that's only growing. So how do you optimize for being predicted? So let's shift over to some tips for that. I guess, in general, the term latest is greatest, and I think that can go for a lot of things, in IT in general. It's a good rule of thumb to follow for maximizing your deployments with pre-provisioned service capabilities, whether it be for an image, a feature offering inside Azure, a VM size, etc. Let's quickly focus on images. Using the most recent image release from Windows or Linux will ensure you have support at the image level. And when specifying the version of your image, going with the latest version will help boost predictability. There's a higher probability that it's going to be, pre-created already. And the last point I think, is super key. Leveraging Azure's platform image repository or the shared image gallery. So whether you're optimizing for, CPU, storage, memory, every VM family has either, a premium or a standard SKU. These terminologies more or less map to the existence of an S in the name of the VM, but there are exceptions. A simple example here would be for the general purpose D family of VMs. There's the DV4 series and there's a DSV4 series. The DV4 series is considered, standard, and the DSV4 is considered the premium. What this really maps to is the kind of stack that it runs on behind the scenes. Premium is running on our latest stacks and standard on something older. So for better performance options, choose the premium VM SKUs. Another note on the virtual machines is making sure you have the right size. Max IOPS or IO operations per second, speaks to storage throughput. This will depend on the VM size and the size of disk. So, if we are in a shoe store and you're between sizes, my recommendation is to skew to the size up, and that will reduce the potential of IOPS throttling during VM provisioning. This is, of course, you need to balance this with cost as well as your business needs. But I guess, the same philosophy can be applied for premium versus standard storage. And look, there are also several availability offerings for virtual machines. If you can use the latest availability offerings, using availability zones or the recently, public previewed virtual machine scale sets with flexible orchestration over availability sets, you're going to be in a much better state. Availability zones, are going to provide you resiliency against any infrastructure disruptions. And the newly announced virtual machine scale sets with flexible orchestration, lots of benefits here. I can't even begin to list these, but of course, it's going to be fast. It's going to be scalable, customizable. And look, I guess the combination of pre-provisioned virtual machines as well as these functions will, ensure that you are on the right track for being able to provision your virtual machines in a timely manner. So look, before we take a break and I hand it over to Patrick, here are some resources that I've linked, that relate to this talk. Actually, let me rephrase that. We're not going to take a break. What I'll do now is, I'll give you a few moments to digest this slide here, and then we'll cut over to Pat, to lead us on into the next session.
Hey Shane, so there were just two questions, and I don't know if you can answer them now, or if we could try and get the answer and post in the chat. But one was, how do we leave the first 1 megabyte free And then a follow-up to that is any special configurations during the image build process. So not sure if you've got those, but if not, we can try and get them during the talk.
Yeah, thank you very much for the questions here. So look, in terms of leaving space free on an OS disk, it will depend on the operating system that you're using and how you build your image. What I'll do though is, whilst I'm not talking in Pat's here, we'll see if we can drop some links in the chat that specifically answers that question there.
Fantastic.
Along with any special configurations during the image build process.
Okay, awesome. All right, well, we will now hand over to Pat, and then we will get Shane back on shortly. So I'm going to welcome Paddy to the stream and add his deck. So over to you, Paddy.
Thanks, Michael. Thanks, Shane, and thanks everyone for joining us today. Great to sort of see a good crowd listening in. Yeah, for those of you who don't know me, my name's Patrick or Paddy Cannell. I'm the Azure Engineering Business Lead for Australia and New Zealand, previously based for just the New Zealand business, but now across ANZ, but still based in Auckland, and sorry for all of those of you still experiencing lockdown. So today we're going to go backstage behind the scenes with Azure FrontDoor, and that's really to see how we can leverage the global vantage points across Microsoft's global network to self-heal and optimize user experiences all the way from the edge to apps on Azure. Some of you might have seen this slide before, particularly when we've done our data center region updates, but this is what Satya likes to call the world's computer from a Microsoft perspective, and that's what he likes it to be. Think of it as putting Bill Gates' concept of putting a PC on every desk. Well, let's see if we can put a data center region and an edge point in every country where we can. And so this is our interconnected network connecting those data center regions and edge sites, and actually makes us typically the third largest telco globally by sheer meterage of mileage that you can see here of undersea and various other fiber connectivity. And so Azure FrontDoor is part of this, and it's a versatile service that can improve the security and reliability and performance of applications by providing access to Microsoft's huge network that you see here with just a few clicks. And as Microsoft has really bet on Azure FrontDoor over the last 8 years, it's been battle tested and now delivers 80% of Microsoft's own SaaS services in addition to Microsoft's Azure customer services. So it has been matured and scaled globally to meet the needs of most of the demanding enterprise experiences and services across the planet. So it's a pretty cool solution. FrontDoor plays multiple roles in cloud architecture solution for internet-facing apps and content. It provides a perimeter security service to improve security. It serves as a global load balancer to improve reliability, and it provides content caching and app or API acceleration to improve performance. And so instead of being deployed in Azure regions, FrontDoor is actually deployed to more than the 180 edge locations that you see on this map in key metro locations at the edge of Microsoft's WAN, and connects back to Azure via Microsoft-owned or operated fiber. You'll never see any of our connectivities going through third-party IPsec connections, by the way, and one of the few cloud providers that actually do that. It's all managed by Microsoft, either owned or operated by us. And so we're sort of rapidly expanding this offering at almost an edge site per week. And we recently even expanded to the likes of Morocco and Angola, and also started to add to sort of wider countries or larger land masses such as the US, where you've got, and Europe, where you've got different states or regions that we haven't catered for other than the edge of those countries. And so having these global vantage points to low latency to end user devices typically is about 30 milliseconds on average, but allows FrontDoor to provide a unique service that enables an application to leverage end-to-end fast network-aware self-healing capabilities. And so that means that it can help for your application issues as well as your internet or infrastructure issues. And that's what we're going to talk about further today in this session. Also think about this as I talk about it, how this might help when you're experiencing DDoS attacks. Those of you who've been in New Zealand and Australia recently, you have seen quite a flood of the last mile with nation-state attackers using DDoS to flood the networks. The likes of Azure FrontDoor can certainly help with that. Okay, so as I mentioned, FrontDoor sits at the edge of Microsoft's network, and it's across those global vantage points. And so connecting these sites is Microsoft's controlled fiber network that provides a high-quality path between each edge site and, of course, our data centers. And FrontDoor serves as that bridge between users and devices on the internet and applications hosted or even inside or even outside of Azure. So FrontDoor leverages Anycast, a network technology, to localize and draw in end user traffic to the closest location to that end user and then routes that traffic to the application. Because FrontDoor can see the full path between the edge and the application as a load balancer, it can quickly detect any damage, any failures or increases in latency within your application or even between an application and the edge. And once that's detected, FrontDoor can actually help an application auto-heal by routing traffic to healthy regions or endpoints. And this gives your users a continuously optimized experience, which is pretty cool. And so that makes it better than DNS load balancers. So FrontDoor is a proxy and terminates traffic at the edge, so it can make more quick responses to route around failures. DNS relies on wait times, TTLs that need to cycle before it can reroute traffic after an outage. And unfortunately, these TTLs are often high in terms of their impact and take time and impact your overall performance. And so not every network or device respects these TTLs either. And this can be particularly bad with mobile or enterprise networks, which often are overridden by TTLs to limit the rate of change to the DNS. And here you can see an example where it took greater than an hour to get to 95% convergence to self-heal after an outage, versus FrontDoor, which reacted much quicker since it didn't need to update DNS or change the IP addresses that the end user devices see, and it quickly rerouted those new connections to the healthy data center. And so, as I mentioned earlier, FrontDoor doesn't just focus on healing application issues, it's able to help applications self-heal end-to-end. So FrontDoor sits at the edge, like I mentioned before, to the edge of the internet and behind the scenes, and also helps to optimize the reliability of the connections that come from end user devices to FrontDoor and self-heal issues outside of Microsoft's network. It's important to note that, outside of Microsoft's network. With the help of technologies like Anycast for fast convergence, FrontDoor already provides an enterprise-grade solution to internet routing. However, it also takes it to another level by seeing the path between users and FrontDoor services in real time and then dynamically routes around internet issues wherever possible. And so our solution to this is called Map of the Internet, rather creatively named. It's a service that sees global internet quality from end users, and it's deployed in many Microsoft products and constantly monitors internet performance and customer experience of Microsoft users connecting FrontDoor in real time. And this system can disambiguate between expected client performance across wired and wireless connections and separate sustained issues from transient ones to give us real-time visibility into the connectivity experience of hundreds of millions of users across the globe. And the map you see on the screen here is a snapshot from one day of global users reporting their internet experience connecting to FrontDoor, with each green dot equaling one or more users. And so this data is turned into a set of signals relevant to geographic routings or groups of users and the infrastructure they use to connect to FrontDoor. And a series of machine learning algorithms then constantly checks for both failures and alternative paths to route around failures should they occur. Again, think back to DDoS attacks flooding a last mile network. If quality degrades through one path and there's an alternate, then the traffic will be quickly rerouted through the alternative path to heal around the degradation and continue delivering the most optimized user experience possible. And so any application using FrontDoor gets these self-healing benefits. And we've now exposed some of this technology that you can use directly through a tool called Internet Analyzer. And so what's that? So let's give you a scenario of how that works. So let's pretend you're operating a service delivered to users in many different locations around on mobile devices, and your app is sitting, hopefully, in 2 Azure data centers. You've got an email from your boss who wants you to evaluate changing how you route that traffic, more specifically how you change your infrastructure, and also factor in new security checks that you want to add in, and whether that will impact performance and the experience for your users. And I can hear some of you saying this sort of sounds like an A/B test waiting to happen. So with Internet Analyzer, you can get an answer to this by signing up, adding a JavaScript tag to your website or client, and hosting a test object in your application or applications. And so Internet Analyzer will then distribute that JavaScript to your clients, which will then test performance to your application and aggregate the results on your behalf. And there's it going aggregate. I should have clicked one more time. I knew I'd bugger that up. All good. All right, so based on those results, it gives you a report for your users that they're using your application, what the difference in performance or latency might be for your users by percentile and at a global or country level scope. And you can leave the Internet Analyzer running, which will continue to give the results, monitoring your application for changes in latency over time. So it's an ongoing service. And so if you want to learn more about FrontDoor and how it can help you, certainly check out these great links that we've set up here for you today. There's some awesome links there in the docs that'll help you understand Azure FrontDoor and Internet Analyzer. Look out for also, if you heard of the fast track for Azure Live sessions, they always talk about our technical capabilities, such as Azure FrontDoor and how to help you. So check out those if you just jump on Google or Bing or whatever your preferred browser is and search up Fast Track for Azure Live, and you should be able to find some events that you can register for. Okay, that is me on Azure FrontDoor and Internet Analyzer. I'm going to hand back over to Shane, but I just want to check if there's any questions in the chat that we need to follow up with afterwards.
No, all good on that one. But we have a question. What kind of propagation delay can we expect for changes to take effect?
Wow, that's a big question.
Yeah.
I will come back to you on that one with some more detail.
Yeah, we'll work on that one and get something posted in the chat. But
I love the word propagation delay.
It's fantastic. It's fantastic. So I'm adding back Shane, and Paddy will be back to deliver another one shortly. So thank you, Paddy. Okay, Shane, it is over to you again.
Thanks, Paddy. Thanks, Michael. And look, just on Hussein's question, look, the propagation delay. So we're talking Anycast for Azure FrontDoor. So whilst I talk, perhaps you can clarify that question a little bit more. If you're talking around propagation for configuration or propagation in terms of, getting packets, to that end destination. If it is, you're talking about from an end user perspective, consuming Azure FrontDoor, being Anycast, it's going to be able to accelerate your content. And there shouldn't be any propagation delay at all. But we'll see what Pat can come back with in the meantime. All right. So look, that was a great session that Paddy just delivered. I really enjoyed that. And content acceleration at the edge is super important for modern day apps, especially in the world of, sparse or single page apps. So if you aren't leveraging, technologies like Azure FrontDoor today in your toolbox of tricks, it's something I would highly encourage you to take a look into. But we're not here to talk about, Azure FrontDoor and content acceleration. We're here to talk about security. So let's click through. And look, I guess in this session, I want to tell a story. And for this section, there are 4 top goals which are important to highlight before we start digging deeper into our discussion. As we go through our discussion today, keep these 4 goals in mind and check each one off, mentally in your head as we cover it. And if somehow we miss one, call us out, post it in the chat here. Love to see if you're all, tuned in, paying attention. But look, first, we're going to determine what generates a security signal. Then we'll talk about the state of security, why it's important to monitor these signals. Then lastly, actually, I did say 4. So thirdly, we'll give some insight into how Microsoft, takes these signals, tunes them, and then gives this back to customers. So here we go, the 4th. And finally, we'll learn how any customer can use these signals, consume them for monitoring security events in your own environment. So story time. And look, it happens every day. There's a specific activity in your company that needs to be monitored in the event for potential compromise. And this activity is quite normal. But it stands out because this normal thing that your users do every day has a different payload attached to it. It could be malware, it could be ransomware. We've all heard the stories. So look, here's a common scenario. A user opens a legitimate looking email. I'm sure you know where all I'm going here. They click on a link and they're whisked away in their browser to a website that looks legitimate. However, upon further inspection by the security team, the email didn't pass, that legitimate muster, as we'd probably say in Australia here, the pub test. And unknown to the user, the website is part of a potentially suspicious domain that's already been reported. And look, once the website was accessed, a download was initiated in the background. It could be some embedded JavaScript, etc. The user knows nothing about it, but sure enough, after that secret download, a process on the user's device is initiated. Something was installed. Even if this ultimately turns out to be nothing, we still want to know about it, right? To be able to secure our environments from this type of activity. Whether innocuous or not, this needs to be recorded and monitored. So all of your digital assets in your organization can be protected.
Shane, can I just pause you for 1 second? You've just got the sharing screen bar just covering up.
I see that. Let's just hide that.
Beautiful.
There we go.
Thank you.
Thank you, everyone. All right. So, we've got the alarm bells going here. And I guess, have you ever wondered, how this type of activity gets recorded, cataloged, and how does the rest of the world know about it? So look, let's spend some time together now talking about it, and let's see how all of these efforts are integrated together into Azure so you can take advantage of these signals in your own environment. So before we dig into the discussion about, the path a threat signal takes from farm to table, or I guess from, user activity or signal through to threat intelligence, let's discuss, why it's important that this actually takes place, why it happens. We all know, security is a constantly moving target. Threats are constantly evolving because as these security signals are turned into threat intelligence, actors, keep altering their methods. It's a game of cat and mouse, right? Threat actors evolve alongside threat intelligence. So, it's a moving target here. Mass distribution malware has been with us now for several decades, and it is still a basis for what we see today. Mass distribution malware has evolved into malware that is targeted at individuals and organizations. And the past few years, we've seen an increased investment by these threat actors into evading file-based detection, using potentially PowerShell to load the attack code directly into memory, or perhaps another, programming language. And now, recently, we've seen the rise of liver for land attack campaigns that involve no malware at all. These frequently target online SaaS offerings, such as Office 365, and involve methods like social engineering, could be credential theft, and leverage native platform capabilities like a document download, forged emails, delegation forwarding rules, and even PowerShell scripts. Now, this is just an example of the evolution or, some of the current attack vectors. So as you can see, it's important that these, threat activities are monitored using some unique and comprehensive methods to expose user activities when they represent actual threats. So let's talk about Microsoft here. We are constantly collecting threat signals and turning them into valuable threat intelligence that can be used by you, our customers. So let me talk you through, how this works. And these numbers, they're just staggering here. So Microsoft's Intelligent Security Graph is a series of interconnected systems that enhance our security capabilities with data, machine learnings, and as well as human insights. Humans are incredibly important here. We have learned that successful use of threat intelligence requires a large, diverse set of data, extensive integration into process and tools, and we have invested in both of these so that you, our customers, can take advantage of it. And look, at the current time, we process over 6.5 trillion signals each and every day. That's staggering. It's a huge number. And we grab these signals through the use of our services like Office 365. You, our customers, are generating these signals. Through these signals, we have unparalleled views into cybersecurity activity that gets turned into threat intelligence. I'm sure you've probably heard in the news from time to time, new variations of viruses being detected or malware, via Microsoft security. This is the process that's happening on the back end. And look, I bet you didn't know that Bing is a security tool. It's not just a search engine. Want to better protect your environment and at the same time, limit the number of advertisements, following you around on the internet and your mobile devices, use Bing as your search engine here. And I guess on top of all that, we've layered shared threat data that we get from our partners. Partners can feed in from the researchers here at Microsoft who are part of our 3,500 plus people workforce that are full-time focused on security, as well as law enforcement agencies that we partner with worldwide through the digital crimes units, as well as botnet data that we collect through digital crimes units. And all of that intelligence makes up the intelligent security graph. As my shirt says here, I need coffee. Hopefully you've got coffee or something like that to keep you tuned in here. So visibility is important, centralized visibility. Many of our customers are familiar with Consolidated Security Console at security.microsoft.com, which brings together Defender, Office, and MCAS products, amongst others. But for true centralization, there's two aspects of our cloud service that provides holistic overall view of security signals in the environment. So we have Azure Security Center and Azure Sentinel, and they provide different capabilities with complementary purposes. So we'll start with Security Center. It's focused on protection and governance of Azure workloads by assessing risk to them, reducing the surface attack area, and generating alerts on potential threats using advanced threat detection technologies. The roles, who use, and so on will differ. But typically it'll include security engineers, risk and compliance professionals that report risk, into a CISO or, a similar person in your environment. And then we have Azure Sentinel, which is focused on monitoring all environments. So Sentinel allows for monitoring alerts and security-related events from any source. So Microsoft Security Solutions, third-party, custom rules. And Azure Sentinel is built for security analysts and security operations centers to make their work easier and more effective. Like a sluice box, Azure Sentinel can catch any remnant of any potential threat to the environment. Even those services at security.microsoft.com can be connected to Azure Sentinel to supply a single centralized console for everything. We all like that single pane visibility. Now, there's yet another piece of this service that might get overlooked, but equally as important. It's also somewhat revolutionary in the way it works. Sentinel is built on technology that allows easy sharing of content. This enables organizations that use Azure Sentinel to develop their own collateral for monitoring and exposing the latest threats, and then making those available for collaboration. This capability also provides value from Microsoft to our customers. At Microsoft, our products follow a defined DevOps pipeline, ensuring that any updates or feature enhancements or even new threat intelligence can be supplied directly to our customers. And a couple of great examples of this are provided in some recent publicly known situations. First, the case of SolarWinds security flaw in early 2021. I'm sure you've all heard of it, but if not, Microsoft was able to deliver guidance and monitoring capability directly to our customers through Azure Sentinel in a matter of hours so that our customers could identify whether or not they were impacted, which is great. Secondly, in the case of the recent Kaseya and Print Nightmare situations, Sentinel customers were able to quickly develop their own intelligence to protect their own environments and then share the collateral and knowledge with others in the Azure Sentinel customer community, enabling them to protect theirs. That's fantastic. So customers are never alone. We are all in this together, whether it's through partnership with Microsoft or through participation with peers. They can rest assured, that the best approach to an organization's security is full of wealth of knowledge, and that's shared and not hoarded. So not a hero mentality here. Sentinel follows the same DevOps pipeline, as I mentioned before, that all of our products follow. So we use GitHub as a piece of that pipeline. Most of the content provided here is fed into Azure Sentinel automatically. So Azure Sentinel customers have the ability to utilize the most current indicator when it's available. But there's also some content that has been supplied for specific purposes. Case in point, the recent SolarWinds situations as a good example, or has been supplied by our customers or partners in an effort to crowdsource security coverage. So if you're interested in this, and I'll pop a link in the chat here, you can go to aka.ms/AS GitHub, and you'll see folders and files for detections. So let's talk through how we can take a detection from a GitHub repo and use it in your own Sentinel implementation. Accessing the GitHub repo for Azure Sentinel is easy and available to everyone. The repository contains content and collateral based on those threat signals that have been either developed by us or supplied to by our customers. One area of particular interest is the detections folder. This folder contains analytics rules that contain the logic needed to look for threat signals in a customer's environment. Once enabled, these rules run on a defined schedule and continually look for that something that it's been designed to look for. If it finds that thing, the security team will be alerted and provided enough information, additional context to know what happened, who did it, what they did, determine the business impact and how to respond. And then evolve, help customers evolve their security operations to streamline this process, in the future with possible automation. So we're, surfacing a new event and then providing a mechanism to potentially automate this in the future. So to install an analytics rule into your own Azure Sentinel environment from a GitHub repo, just navigate to the detections folder to locate something of interest. Once you've found an analytics rule of interest to you, you definitely would suggest, click on the raw button. I'm sure you're probably familiar how, you've often cut and paste and certain characters potentially have been inserted. So ensure you click the raw function to sanitize the code so you can use it immediately without, having to jump through hoops to, properly format in what you've downloaded. So once you have the analytics rule information from which you want to create a new alert, simply go to the analytics blade in Azure Sentinel and choose create a new scheduled query rule. Start with entering the required information to identify the new rule, including the name, description, and severity, and then move on to include the query logic, which hopefully, you can grab from your clipboard. You've probably pasted it into your favorite IDE, which you've grabbed, that from the clipboard was from the GitHub repo. Actually, paste in the comments here. I'm curious, what is your favorite IDE? Do you prefer tabs? Do you prefer spaces? Love to hear. All right, so look, now the code, you've sanitized it, you've pasted it in. Let's take a look and see what is needed to create the analytics rule properly in the rule creation wizard. All right, so we're pasting our content in. We've got our rule query. Look, at this point, as I mentioned, it's just a copy and paste operation from GitHub directly into the analytics rule fields. You could copy the rule name from GitHub, paste it into the name of the analytics rule, and so on, and step through the wizard to save this. Once you save a new analytics rule, it immediately begins searching for data collected in your environment for that thing, that you just told it to look for. So look, I'll demonstrate this to you. We'll walk through the process to show you how easy it is and how anyone can do this. All right, so we've got a bit of video here. Hopefully it's all playing for everyone. So let's create our own analytics rule from the collateral that is provided to us from Microsoft on the official GitHub repository for Azure Sentinel. So in my browser here, I've got two tabs open. The first one is the Azure Sentinel console. Hopefully it looks familiar. And the second tab here is this GitHub repository I just spoke about. Now, the first thing we want to do is go into the detections folder. This is where the logic exists that we can use to be able to create our own analytics rule. Now, I'm going to go through and find something of interest here. So we've got the Office activity folder. Office, of course, one of those services that we can connect to Azure Sentinel, where we can monitor what end users are accomplishing within their environment. So look, here's one called rare Office operations. Sounds interesting, probably something that we want to identify and potentially try and expose within our environment. We can see here that it tells it that this is rare and potentially high-risk Office operations. Gives us the description. This is all the information that we're going to need to supply into Azure Sentinel to create our analytics rule. I've clicked the raw button. As I mentioned before, it's sanitizing, it's stripping away all special characters. I'll just give you a few moments to take a look at this before we'll go into the Azure console. All right, so we're back in the Azure Sentinel console, and we're going to go to the Analytics Rules blade. We're creating a brand new scheduled rule. Scheduled rule, is going to run as it sounds on a schedule. Just close that. All right, so we're creating a new rule here. And we want to tell it what to look for. So it's asking me for a few things to start with. As I need a name, a description, I guess some of the MITRE attack tactics that are associated with this. Now, I may not know this, right, because I'm utilizing GitHub content. But as you can see, if I go back and I'm looking at this code here now in my browser, I can, quite often extrapolate this data out. So I'm just copy and pasting into the applicable fields. The description is also provided here, so I'm copying in that as well. So the severity guidance for this, around the specific object here is quite low. Obviously, we can change this based on what we know about our environment, but I'm going for the recommended guidance on what we know from the GitHub repository. So I've set that to low. All right, so I'm going to go to the next step here. So we're looking at the query logic that's going to be supplied, and that's where I'm going to copy and paste in my query. And once I paste it in, it's going to verify or not whether this query is going to work. So some of the other things I'll need to fill out here, around query scheduling and the alert threshold. Now, all of this is supplied in the GitHub repository. Obviously, you can alter this, but I would recommend, leverage a template and as a good, starting point in your environment. You may want to run the query on a different schedule here. So I guess we're using this guidance from the existing analytics rule. All right. So as you can see here, we're right at the end. We're about to hit review and create. Now, I do apologize for that popping up at the moment. I think I'll kill the process for Outlook. All right, so we're right at the end. We've passed our validation. This is hopefully you'll see it's validated right away. Obviously, this is going through a vetting process, just like everything that happens in Azure goes through a vetting process. And look, this is a really, I guess, understated feature inside Azure in Azure Sentinel here. All right, so, this has gone through, it's been saved, it's been created, and now we've got a brand new analytics rule that we created thanks to, I guess, a Microsoft-based rule that's been supplied into Azure Sentinel via GitHub repository. All right, so look, lastly, depending on how tech savvy you are out there, and I know we're all builders, you don't need to wait for us to supply an analytics rule based on a new threat. You can create one yourself. What you saw before was KQL or custom query language, used within Azure. Hopefully you are familiar with this. You can develop your own logic around custom analytics rules. This capability enables you to develop your own detections based on what's critical to your environment. It may not exist. So it also supplies, you the ability to monitor for newly reported threats in your environment. And look, before I hand it back to Patty here, here are some links that we'll post in the chat to various from Azure Sentinel through to, we've got a security exam, SC200, as well as learning KQL. So it's easy for me to say, hey, write some KQL. Maybe you're not familiar with it. So there's an excellent course on Pluralsight to bring you up to speed. And with that, I will pass it back to Patty.
Awesome. Thanks, Shane. We might as well just go straight into it. I don't think Mike's going to jump in this time by the looks of it. So we'll kick on and make sure we get through this. I think there's only this session and one other, so stick around, folks. Won't take too long. So we're going to talk about ARM templates, but more around how your resources are actually deployed using ARM templates. If you don't know what ARM stands for, because Microsoft loves acronyms, it stands for Azure Resource Manager, which replaced Azure Service Manager as an old classic service back in the day, which just in case you aren't aware, Azure Service Manager or ASM, classic cloud computing, goes retired or deprecation in March 2023. So I thought I'd get that information out there. If you're still on ASM, you need to be on ARM or Bicep, which you'll also hear about me talk about today. So let's get into it. So if you're using Azure, hopefully you're familiar with the Azure portal, and hopefully most of you are using Azure that are on this session today. But did you know that nearly all your resource creation and update tasks are done by deploying an ARM template? And so that's exactly what we're going to talk about today and how that works. One of the things that most people do in Azure is create a VM, and Shane's already touched on that briefly today. It's something most in IT have a good grasp of, and it's also a great way as a jumping off point into Azure. And most of you will be familiar with the VM create experience we're looking at now, where you can fill out all the pertinent settings for your resource. Once you fill out this form, you can go and create to review and create, which you can see here, where the portal will do one last check to ensure it'll deploy. On this tab, once the validation passes, you can actually create your resource with the create button, just in case you missed the word create. What you could easily miss, though, is the link on the right where it says download a template for automation, because it's not as bold as the word create. If we click this, we'll start to learn a bit more about how the portal is going to deploy that VM. If you haven't seen one before, this ugly thing here on the right is actually an ARM template, which itself is written as JSON, which is otherwise known as JavaScript Object Notation. And this particular ARM template is quite literally what will be used by the portal to deploy the 4 resources required for that virtual machine. You might notice them referred on the left-hand side, such as network interface, network security group, public IP address, and finally the virtual machine. At this point, it's not super important that you understand how to read or write this ARM template code, only that it's being used in the process. And so how does this actually work? And what actually happens from the moment you deploy a template to actually getting whatever resources you specified, like the 4 resources I mentioned before, and get them deployed? And so the first template itself needs to be submitted to the Azure Deployments API. Here we go. This can be done by clicking the create button in the portal, or you might be using something like CLI, but they all do the same thing. That template then gets submitted to the deployments runtime, which is ultimately responsible for evaluating your template code to resolve all references and so on. An example would be this little code snippet you see here, which is a reference to a parameter. It's up to the deployment engine to resolve that to the actual parameter and the value provided by the user. Once all of that has been resolved, the runtime will talk to all the other resource providers as fast as possible to actually get your resources deployed. If you've ever heard of resource provider, it actually is a set of APIs related to a class of resources. And of course, common resource providers include compute, network, storage, etc. While this is simple enough, the confusing part tends to be this deployment's runtime. Lovely use of question marks there. There's a lot of magic happening here, and to most, including myself when I started, this was very confusing and sort of kind of felt like it was in a bit of a black box. And so the rest of this talk is meant to provide insight into what is actually happening, and which hopefully will give you more insight into what you are authoring or debugging around your bicep or ARM template code. And so when you submit a template to Azure, there are several steps or checks that we can go through to ensure, to the best of our ability, the template will succeed. First, the first thing you need to do is the basic syntax validation, which is checking all of your ARM expressions. In this case, we have a full stop or decimal point missing between the resource group and location, which is a basic syntax error. The next step is called pre-flight validation, which is a little more advanced, but it will actually check the values you're providing and that they will end up working. And so, for example, you might have a website name that already exists or an IP range that's already taken. And we do this by sending the projected PUT payload to the resource provider so they can all validate themselves. And when we're on the Review and Create tab, validating our VM, it will actually be running in pre-flight. Once pre-flight is passed, then we actually deploy resources. Woohoo! And the passing pre-flight is not a guarantee that the deployment will succeed, but it is a good indication that it is likely to succeed. And you can still have runtime errors just like any other programming language, so it's important to recognize that. One last thing as I want to mention is another capability that we called What If. We're very creative with our names. So some of you may already know about this through the use of CLI or PowerShell, and it predicts what the deployment is going to do by comparing your ARM template to what already exists in Azure so that you'll know if the resource is going to be created, updated, or removed. What's nice about it is if you run What If, it runs all of the validation checks that happens during an actual deployment. So running what if is a really good habit to get into as a final validation before actually submitting, since if you know it passes a what if validation, you know it will therefore pass a deployment validation. And this is what a what if command will return. As you can see, it will give you more context on what is going on and what is going to happen with all the expressions resolved, which is another opportunity to verify everything looking great. So now we're in the deploy phase. The deployments engine is actively sending the PUT requests to create these resources. As I mentioned earlier, the deployment services will try to deploy things in parallel wherever possible. In practice, there are often dependencies between these resources, so the deployment services puts together an execution graph to determine the proper deployment sequence based on the property in your ARM template. And that's called depends on. So let's look at the execution graph for our VM deployment. Conveniently, in the same screen where we were on before to download a template, there is a visualize template button that will show me or you the execution graph. This visualization is a bit confusing because the edges of the graph, the VNet and the public IP address will first be deployed, and then the NIC, and then the VM itself, and will be deployed last. I prefer to flip this and actually so we can follow an execution order from the top down, just to be different. So starting from the top, we will deploy the networking resources. Then the deployments engine will poll continuously until the resources finish deploying. Once that's done, we will move on the NIC or NIC. And if I go and look at the section of the ARM template, that describes those resources. And I'll see an explicit depends on statement, like you can see here, specifying the resource IDs of those networking resources. The same story for the VM. Once the NIC is done deploying, we will move on to deploying the virtual machine, and there is a corresponding depends on statement instructing it to wait until the NIC is done. And one thing to note, the need to explicitly specify dependencies like this is a common source of errors for both new and experienced ARM template authors. And later in the presentation, I'm going to briefly touch on an improvement to this and ARM templates called Bicep, which sits on top of ARM as a solution. Among many things, it improves the needs and removes the need, to specify dependencies almost entirely, which can make things a lot easier for you. So when your deployment is done, one thing that most people don't realize is that a new deployments resource is actually being created. It's a resource just like a VM is a resource, and in that resource, we store metadata and logging info about what took place during that deployment. And you can view this in the portal, which is what we're looking at now. And you can also view this in the CLIs and SDKs. Two important things to note about the info provided in the deployment resource. The first is operation details, which is information provided by the resource provider. If you ever have an error in your deployment, you will likely find helpful information here. Sometimes the resource providers won't provide helpful information though, and so you may need more help and open up a support case just in case. The second important piece is the correlation ID. Which helps the Azure support team look deeper into the logs that we aren't able to make available to end users. Hence the support case reference. Okay, so up until now, I've talked about ARM templates, and I've briefly mentioned Azure Bicep. We've talked about the advantages and benefits of the likes of pre-flight and validation. But we're actually going to recommend you start looking at a new language, which is built on top of ARM templates called Bicep, like I mentioned before. And so Bicep really aims to give you all the benefits of templates without some of the challenges that usually come with authoring and debugging those templates. Under the covers, when you deploy a Bicep code, we transpile this into an ARM template before it deploys. So all the knowledge of the inner workings of deployments will apply to Bicep as well. And this bit of code that you see here is what it looks like, and hopefully you can see it's fairly easy to read and work with. So your call to action really is to start thinking about how you can learn the new language of Azure Bicep and that code, and experiment with getting names wrongs and letting pre-flight validate things for you, or try out what if to get a sense of what it means to predict an Azure deployment. We've put together a whole lot of Learn modules that walks you through every detail of Bicep in depth, and that's available via these links you can see here, or the one on ARM templates. and that is an update on ARM templates and how they're resourced and then deployed, and a bit on Bicep. So hopefully that was really helpful for you. I think we're now handing back to Mr. Shane Baldacchino and one last session to keep you entertained for the day.
Thank you, Paddy, and thank you for your 2 sessions. Yes, we are going to be hitting our last session for the day, and it is my pleasure to bring back Shane. So please remain with us for a little bit longer, and that will be the end for us. Thank you. Shane, we can't hear you for some reason. There we go.
How about now? There we go. I was going to say, Alan, absolutely loving the chat. I was just about to look for a URL to find a via cut, but I'm sure you know what I'm talking about. And, Paddy's session just finished on Bicep. I think as we all move through our, cloud maturity journey, depending where you are today, you may be at the beginning, or you may be, quite mature and climbing that curve. Perhaps you're not using the console. You've gone from using things like, AZ CLI, you're building your own ARM templates. Perhaps you've moved on to Bicep. But what I will say is, Bicep is, it's moving away from that declarative syntax language, to one that enables you to leverage your IDE. That, if you want to create a for loop or, have a more rich experience, it really is going to be able to help, the more developer-centric folk build automation within Azure for deploying resources in a mechanism that has, far less rules than ARM. And as Paddy said, the artifact of Bicep is ultimately an ARM template. So look, thanks for hanging in there. As I mentioned, I love a good ARM template, but now I think, it's time to learn how to start, flexing those biceps here. So we're going to finish today on cost. And I think, such a great way to finish today's session. And one of the many benefits of cloud is, obviously performance and reliability are no longer mutually exclusive to being cost optimized. There is so many knobs and levers in Azure for you to pull and turn. You can really drive down your, cost of doing business without affecting performance and reliability, security, etc. They're no longer tightly coupled together. So to get started with this session, let's look at Azure Advisor. Hopefully you're familiar with this already. So I'm just going to play a short video. And look, here is, a recommendation on cost. And as we can see here, we've got, a very common optimization that gets shown to lots of Azure customers. So, right size or shutdown of underutilized virtual machines. In this example, you might, you'll see here that the suggestion is, you can resize your virtual machine named, Reco Test from a standard D16 SV3, rather large one here, which is a 16 core machine, through to, a D4S V3, which is a 4-core machine. In doing that, that's a saving of over $10,000 a year on Azure costs. Not bad for a single recommendation. So look, if you're not familiar with Azure Advisor, note it down, take a look, but let's walk through how we produce this information. The Backstage tour here. What we do is, we start by looking at how each and every VM in the Azure fleet is getting utilized. So don't worry, we have no idea what kind of workload you're running and what context a VM is being used for. So remember, the shared responsibility model. We have no context, no insights into memory, etc. If you're not familiar with it, you can Bing or DuckDuckGo, Azure shared responsibility model, pop that into your favorite search engine. But, we boil down the telemetry to percentages of CPU, memory, and network utilization. So the chart that you're looking at now depicts the current utilization over 7 days of this sample VM. The blue line is the CPU, the pink line is the memory, and the green line is the network utilization. This maps exactly to the performance counters that you would notice if you remote into the VM. And as you can see in the case of this VM, the utilization never crosses, that 28% boundary over a 7-day period. So the shaded red part, in this case here, occupies most of the chart. This is underutilization. This is resources that you're paying for that is not being used. So the workloads running on the VM simply don't need the entire power that this VM is capable of. So here's another way to look at underutilization. Let's say this graph here is your CPU utilization over 7 days, consisting of metric values for every half hour. So that translates to 336 data points. For ease of analysis, we take the 95th percentile, so we get rid of the peaks here, of all of these values to base our calculations on. Sorry, I lost my train of thought here. So, we're discounting the non-typical spikes. So in this case, let's say the 95th percentile corresponds to 10%. Similarly, we do this with memory utilization over the past 7 days. And in case of memory, we consider the 100th percentile, which is essentially the max value observed. There's a difference in the percentile values considering between CPU and memory. And that's because most workloads can handle the CPU peaking out. But, if the memory peaks out, you're going to potentially, have to swap to disk, slower than expected performance, and applications can fail. So we're extremely mindful, ensuring that you have a good time on Azure, you're having the best experience, that your application remains performant and reliable after adopting our cost recommendations. So in this case, let's say the 100th percentile for memory is around 18%. And we can represent the total capacity of the VM for both CPU and memory as buckets, i.e. when the bucket is filled up, all of the resources in the VM are used. In this case, you can see for CPU that only a tenth is filled up for memory, and around 18% of the bucket is filled, out of our 64 gig. The empty space in the bucket represents underutilization. So as part of right-sizing recommendations, assuming the utilization is fairly constant, what we're trying to do is move you to a different bucket, such as the empty space is minimized. The D16S V3 is a VM with 16 cores and 64 gigs of memory, rather large. Maybe someone who's not paying the bill has, chosen this, or maybe there wasn't enough metrics, data to help select the right virtual machine instance size. So assuming utilization stays constant, we can quadruple the utilization by using a bucket that is a quarter of a size, i.e. by moving to a VM that's 4 cores and 16 gig. The CPU utilization now increases to 40% and the memory utilization to 36%. Even if we use an even smaller bucket, we can drive utilization even further. In this case, we've halved the bucket size again, resulting in utilization to reach 80% for CPU and 72% of memory. So, I'm sure you're all aware there is a large variety of SKUs that Azure provides to help you choose the right size. And, we spoke about it earlier, latest is greatest. If you think about as newer virtual machines be released, they often provide a better cost to performance ratio. So, Patty just mentioned, if you're not using ARM, absolutely get onto it because, the old, mechanism for deploying pre-ARM is being deprecated. Virtual machines are kind of like, in the same boat here. You want to be thinking about, infrastructure as code, how you can, not be tightly coupled to your environment and, deploy on newer machines on a regular basis and smaller if need be. So how did we land on the specific size we've shown in the recommendation? As the slide, says here, it's based on targets. We identify what we want the ideal max utilization to be, and try and then choose a size that will get the utilization closest to the target without going over. You may be wondering, what's with this distinction between user-facing and non-user-facing loads? Or perhaps you're curious how Microsoft knows which one you are running on your VM, because we don't actually know what you're running on your VM. So look, let me answer that question first and then discuss the second question afterwards, because to me, this is where some of the magic really happens. User-facing implies the workload is directly processing user requests, and non-user-facing implies that the workload might be processing, batched scheduled requests. Since user-facing workloads are more critical in nature, we give it a lower target of 40% for CPU and 60% for memory. Non-user-facing workloads are assigned a target of 80% for both CPU and memory. So this is how we finally land on a recommendation based on the size that will get us closest to the targets, and it's the cheapest options for our users. But what about, how do you know whether or not we're running something user-facing or back-end facing? After all, we have no visibility into your virtual machines. That's a really good question. All right, forgot to click through there, but hopefully you can see, hopefully the graphic makes a little bit more sense now. Again, we don't know. So here's the magic. This is for me, part of this Backstage tour. How are we doing this? So our friends at Microsoft Research did some really interesting research and learned, it is actually possible with quite a high degree of confidence to determine whether a VM is running user-facing or non-user-facing workloads by looking at the waveform, of the average load of the virtual machine. So if you were to graph the CPU utilization, the memory utilization, and they've published research that you can read to see how this is done if you're inclined. I think this is pretty cool. So now let's look how we create a right-sizing recommendation that you actually see inside Azure Advisor. Firstly, we collect CPU, memory, network, and telemetry data, which we're able to retrieve from the Azure host machines running the VMs. Again, don't worry, the data is completely anonymized at this point, no context of the workload being run. So the data we sample every 30 seconds, and then we aggregate it over 30 minutes. The max values are considered during aggregation. Then we look at 7 days of utilization telemetry to create a recommendation. So when you deploy a virtual machine, instantly there's not going to be a recommendation. It takes time to be able to, sample, have enough data points to be able to provide that recommendation. So to summarize, we compare the utilization with what it's capable of. We identify the type of workload it runs and assign targets to it. Remember, user-facing or non-user-facing. We find a VM size that results in the utilization of the CPU, memory, and network to be as close to the target, but not above any metric. If multiple options exist, we pick the VM size that results in the most cost savings. Currently, we provide within series recommendations only, which means, if you're on a DV2, we'll make a recommendation that asks you to move maybe, to a smaller instance within the same family. So we're planning on expanding our recommendation to include VMs from other SKU families, which hopefully will result in even more savings. So, stay tuned for that. Look, and in all cases, we ensure that there is not going to be any performance or reliability hits to the workload after adopting our recommendations. All right, so what we do after all that, we land on this recommendation, we push your utilization higher, we give you the highest cost savings while not impacting performance or reliability of your workload. If you aren't leveraging Azure Advisor, or if you're not doing it on a regular basis, I encourage you to look at it. But, this requires human interaction here. How can you automate this? So everything inside Azure is surfaced via an API call. Perhaps you could, leverage Azure CLI, tie it into your monitoring platform, etc. Find a way, hopefully, that you can surface these results and alert these through to you. Many ways to do this, by the way. So, we've started off, on a really large machine here. We've changed, and, you get to optimize your Azure costs for the same performance and reliability. Obviously, your mileage may vary, but I strongly encourage you, definitely to do this on a regular basis and, leverage Azure, not like your traditional data center. It has all these additional levers and knobs that you can turn to, tune your compute and pay for only what you're using. All right, so now let's quickly look at another of the recommendations on cost optimization that gets shown to the greatest number of Azure customers. All right, reserved instances here, or RIs. What are reserved instances? It's also known as a reservation. So if you have constant VM usage, and that VM supports reservations, buying reservations gives you a really good option to reduce your costs. For example, when you continuously run instances or VMs without a reservation, you're charged as pay-as-you-go rates. No long-standing commitment, pay as you go. But when you buy a reservation, you immediately get the reservation discount. The resources are no longer charged with pay-as-you-go rates, and reservations help you save money by committing to either a 1-year or 3-year plan for multiple products. So, same performance, same reliability, it's the same machine, but it's helping us, capacity plan. So, the premise of cloud is, you don't need a capacity plan, but ultimately on our end, we do. So by confirming a reserved instance, a reservation, it gives us consistency, and at the same time, it provides you, deep discounts, up to 72% less expensive for, certain virtual machine instances. After you purchase your reservation, the discount automatically applies to the matching resources, and there's no need for redeployment. So it's effectively we're matching line items in your bill. So it's also an advantage for Azure teams, since we can optimize our capacity planning for VM instances effectively, as I mentioned earlier. 1 to 3 year plan that you choose, it's a win for everyone ultimately. Now, there's a lot of data points that go into this recommendation system. As you can see in the diagram that I'm clicking through here, we take into account, to generate these recommendations. If your resources are shut down regularly, the simulation won't find any savings here because you're paying for it the whole time, right? If there are any special discounts that you might have on your on-demand rates, your usage for the last 7, 30, 60 days, any recent reservation purchases, and usage across each and every Azure subscription. And this all feeds into our recommendation engine. So I just showed you what kind of data that we use to calculate the recommendation. Let's see how the recommendations are simulated. As I said, the recommendation engine evaluates hourly usage for your resource, 7, 30, 60 days. Based on usage data, we're going to simulate your costs with and without reservations. The costs are simulated for different quantities, and the quantity that maximizes the savings is recommended. The recommendations in Advisor are based on a single scope and based on the last 30 days of usage. In the chart that you see here, the VM usage fluctuates quite a bit from 35 VMs to 70 VMs. And the recommendation is to purchase 45 quantity of VM instances as it maximizes the savings, even though the utilization may not be 100%. Now, I challenge all of you on the call today, do you have a target for VM reservation in your environment? Some organizations may strive to hit, 80% of our instances must be reserved instances. Perhaps set a goal. What works for your organization? What is your low watermark? What is your high watermark? Whether or not, as in the example here, even though it may fluctuate in this scenario here between 35 and 70 VMs, the recommendation is to purchase 45 VMs. So look, definitely take a look at Azure Advisor. We've discussed how these recommendations are calculated. How do I get them? All right, so VM recommendations, as I mentioned, are available in Azure Advisor. Reservation purchase experience in the Azure portal, and the cost management Power BI app, as well as, my favorite thing here, APIs. As you're climbing that curve, consume an API. When purchased, the quantity that Azure recommends will give the maximum savings possible. Although you can buy any quantity you like, if you buy a different quantity, your savings obviously aren't going to be, as optimal. The recommendations are coming from our engines, and they are for a 3-year reservation where available. So, ensure, do your due diligence here, understand your business needs. If a 3-year reservation isn't sold for the service, the recommendation is calculated using the 1-year reservation price. All right. So look, a few links and documentation that can help you understand more about reserve instances. And look, with that, I'd like to thank you for sticking it out. I think we'll cover a few questions and I'll hand it back to Sarah in a second. But look, thank you. We've covered a lot of ground today. And look, I hope you learned a trick or 2 or even 5. All right, and I'll pass it back to Sarah.
Great, thanks, Shane. So we did have some questions come through in that last part of your presentation. So I'll just put those up on the screen for you now and I'll read that out. So Nick asked us, can you reverse engineer existing Azure services you may have deployed using tools to generate ARM?
Yeah, I've got the answer to that one.
Thanks, Pat.
You can hear me all right? Yeah. Yeah, you can. It's not of getting variables into it, but you can extract ARM from the portal itself, and then under whatever resource you want to export that second to last item in the menu, then you can use on the left is the export template, so you can bring it out that way.
Yeah, and just on that, I really like that, Patty mentioned before, often, in the portal, before you click review and create, you can download for automation. And that can also be a mechanism for, building up your repository of automation within your environment. But yes, absolutely, as Patty explained, you can reverse engineer that.
Great, thanks, Shane. Thanks, Patty. So we had another question come through as well from Otis. So reserve VM can save costs. Do you think functions and logic apps can save money on a granular level?
That is a great question, Lord Otis. So it depends, right? So there's going to be a tipping point on a graph where if you've got functions and logic apps that are running constantly, it's going to be more expensive in the fullness of time. You'll be able to map that out than a virtual machine. Potentially you're running containers, another compute workload. It's something you will need to calculate. There is no Boolean 1-0 solution here. It really depends. If you've got function apps, let's just say you've built a single page application that is fully event driven, and maybe it's a brochureware website and you're hardly getting any hits from time to time. Functions and logic apps probably going to be a lot cheaper here. But if you have an application that is constantly being hit on a regular basis, you probably find that it may be cheaper to leverage a group of virtual machines to be able to serve your user base. So it really depends here. I hope that answered your question.
Thanks, Shane. So another one came through for you. So I just put that up on the screen there. What are the recommendations on the data warehouse area with DWUs?
Ooh, I may need to defer this. Patty, are you able to answer this question?
No, sorry, can't give you the answer on that one.
How about
that's another level.
We'll know this
find out for you. Give me a sec. Maybe go on to the next one.
So during that, we'll just answer this last one again from Otis. So in a general sense, how would you define serverless computing? The reason being each cloud provider, CSPs, has its own definition.
Yeah, okay. So look, serverless, I think it's a paradigm shift in computing. And look, personally, if I was building an app and it was greenfield, my de facto stance is always to start serverless. If I can't do serverless, I go back to containers before using traditional compute. So how would I define serverless? It is an ability to deploy code without having to manage underlying infrastructure and pay on a pay-as-you-go model here. But you are right. There are, I guess, no consistent terminology across the industry. But look, realistically, there is no infrastructure to manage. We're going to handle the scaling for you. It's going to provide that faster time to market and ultimately, potentially more efficient use of resources. But I caveat that back with the point I made earlier. If your workload is consistent, serverless won't be more efficient in that scenario.
All right. Thanks for that, Shane. We're just answering in the question section. Sorry, Paddy, were you saying something in regards to that question?
Yeah, I was just going to say, look, just put a link in the chat to and you've done that now for the DW's guidance and recommendations.
Yes, so we've popped that in there with the answer below. And thank you for the questions from Otis, and thank you to Shane for answering them. I think we'll finish it up there for today with questions, unless anyone has any that come through in the next minute or so. Just a reminder that we've put the check-in link in the Q&A as well. That event code is 14636. So if you just enter that code, you'll be able to get majority of the links for today. The ones that weren't able to go into that check-in link, I've already put into the comment section if you just scroll a bit further up. We've also put in our survey for Microsoft Reactor, same event code 14636. If you have time to fill that out today, that'll be great because that helps us curate our future topics. And yeah, we're just going to put in the YouTube link as well and upcoming Sydney events. I'll put that in the question section as well. We're having a lot of people commenting, so thank you so much to everyone for engaging with us during this session today. Thank you again to Shane and Paddy for being here and presenting. Have a good rest of your afternoon, evening or morning, and we'll see you next time for another Microsoft Reactor live stream event. Thanks both.
Thanks all, and thanks for the comments, guys and girls.
Yeah, thanks everyone. Appreciate your time.
Thanks. Bye.
Bye.